So in this video, I'm going to be going over the Chapter 5 review. The first three I can just type into my calculator. So I'm going to go 625 to the 1/4 power. If I have an older calculator, I might want to put my exponent in parentheses. This one gets me 5. My next one is 4 to the 5 halves. That one gets me 32. And my last one is 32 to the negative 3/5. This one gives me a decimal. I'm going to turn it back into a fraction just in case my computer has fraction choices. So I press math, enter, which gives me 1/8 as my answer. The next one wants me to rewrite them as rational exponents. Remember, the index of a radical is the bottom half of fraction in the exponent. So this is going to be 4 to the 4/9. This one's going to be 10 to the 8/11. This one's going to be 27 to the negative 2/3. It doesn't say I want to have positive exponents, but typically I do. So I'm going to rewrite this as 1 over 27 to the 2/3. Remember, negative exponents flip the fraction. So if it's a number that's not a fraction, it turns it into 1, and if it is a fraction, it flips it. Next one wants me to write the following expressions in radical form and simplify. So this one is the cube root of 8 to the 5th. I can take the cube root of 8, so I can rewrite this as the cube root of 8, and then raise that to the 5th power. The cube root of 8 is 2, so I have 2 to the 5th power, which gives me 32. Same thing on b, so I have the square root of 16 to the 5th power. I can rewrite this as the square root of 16 and then raise that to the 5th power. The square root of 16 is 4. I don't know 4 to the 5th power. That gets me 1024. On the next one, I have a negative exponent, so that is going to be 1 over the square root of 25. Square root of 25 is 5. So this one is 1/5. Okay, the next one wants me to simplify the following expressions. All variables represent non-negative numbers. So I can break this up to the square root of 16, the square root of r to the 4th, and the square root of s to the 5th. The square root of 16 is 4. The square root of r to the 4th, I can rewrite as r to the 4 divided by 2. And the same thing for my s, I can have 5 divided by 2. So it's going to give me 4r squared. For my s, it's going to give me 2.5. So that means I can take out 2 s's, and I actually have an s left over in my radical. Another way to think about this is I have 5 s's, and I want 2 groups to come out, and then I have 1 left over. Same thing for the next one. I have the cube root of 375, the cube root of x to the 7th, and the cube root of y. On the cube root of 375, I don't think that's a nice one, but let me double check. It is not. It gives me a decimal. So I'm going to factor tree 375. I know that has 5 in it, so that's going to get me 75, which gets me 15, 5, and 3. So I can take out a group of 5s, and I'm going to have the cube root of 3. For my 7, I can take out 2 groups. So I'm going to have, not my 7, my x to the 7. So we can have x squared, and then I'm going to have a leftover x. And then my y, the cube root of y cubed is just y. So then putting this all together, I have 5x squared y, cube root of 3x. On the last one, I want to rationalize my denominator, so multiply by the conjugate, which is 2 plus the square root of 5. Multiplying across on the top gets me 6 plus 3 square root of 5. On the bottom, I want to FOIL. 2 times 2 is 4. 2 times the square root of 5 is 2 square root of 5. Negative square root of 5 times 2 is negative 2 square root of 5. And then negative square root of 5 times 5 square root of 5 is the square root of 25. Simplifying, I get the top stays the same for now. And then the bottom is going to turn into 4 minus 5, because the 2 square root of 5s cancel out, and the square root of 25 is 5. This is going to give me 6 plus 3 square root of 5 over negative 1. So So I just need to change my signs. I have -6 minus 3 square root of 5. These next ones want me to simplify. My first term, there's nothing to simplify. My second term, I can take the cube root of 8. So let me... Oh, I don't want to there with that. So I have that 9 up front. The cube root of 8 is 2. I can take out a group of 3 y's, and I still have a y left over. So this is 12 cube root of y plus 18 y cube root of y. The ends on these two are different. This one's just a cube root of y, and this one's y cube root of y, so I can't combine it any further. On B, same idea. I can't take the cube root of 4, but I can take out 2 groups of 7, because that gives me 6. So I have 1 y left over. My next one, I have that 2y. I can't take the cube root of 32, but I can factor tree it. So I can take out a group of 2s. That's a little off the screen. And then I'm going to have 2 2's left on the inside. I can take out another y. So I have 4 y left on the inside. I want to simplify that second term. Just going to turn 4y squared, cube root of 4y. The endings are exactly the same. So notice they both have the y squared cube root of 4y. So that means I can add, or subtract in this case, the 2 outside numbers together. So I'm going to get 12 y squared cube root of 4y. The last ones want me to graph the following functions. So the square root of x looks like this. My domain is 0 to infinity, because it starts at 0 and it goes right forever. Another way to write this is x is greater than or equal to 0. Same thing for my range. It's 0 to infinity, starts at 0, goes up forever. So this one would be y is greater than or equal to 0. The next one, I am going up 3, and then reflecting, and a stretch of 3. So it's going to look something like that. My domain, again, I'm starting at 0 and going right forever. So x is greater than or equal to 0. And my range, my high point is 3. So I'm going down forever. And then my high point is 3. So this one is y is less than or equal to 3. This next one wants me to solve my equations, so I'm going to start off by subtracting 1. I have the square root of x plus 6 equals 1. Then I want to go ahead and square both sides. I get x plus 6 equals 1. I want to subtract 6 on both sides. I get x equals -5. Then I just want to go ahead and check my answer. So I have 1 plus the square root of, it's going to be -5 plus 6, and it should equal 2. So I want to simplify this side. I have 1 plus the square root of 1, and it should equal 2. Square root of 1 is 1. 1 plus 1 is 2. I'm all good. So this is my answer. Same thing over here. I'm going to start off by subtracting 2. I have the cube root of x minus 1 equals 1. Let's get rid of my cube root. I cube both sides. I have x minus 1 equals 1. Add 1 to both sides. X equals 2. I want to check my answer. So I have the cube root of 2 minus 1 plus 2 should equal 3. 2 minus 1 is 1. The cube root of 1 is 1. 1 plus 2 equals 3. C, I want to go ahead and square both sides. So I have x plus 72 equals x squared. I want to move everything over to one side. I'm going to move it over to the side where the x squared is because I like dealing with positive x squareds. So I have 0 equals negative x. Nope. I skipped the term. 0 equals x squared minus x minus 72. I'm looking for what multiplies to negative 72 and adds to negative 1. This is going to be negative 9 and positive 8. So using the zero product property, I set these equal to 0. The first one I add 9 to both sides, I get x equals 9. The second one I subtract 8, I get x equals negative 8. I need to go check my answers, and I need to check both of them. So the first one I'm going to check is my 9. So I want to check to make sure that this is going to equal a positive 9. 9 plus 72 is 81. The square root of 81 is 9. That one works. Then I want to check the second one. So I'm plugging in negative 8. Negative 8 plus 72 is 64. The square root of 64 is positive 8. Those are not the same number, so only my positive 9 works. On D, I want to square this one as well, because my radical is already isolated. That gets me x minus 1 equals, if I have that squared, I can write it twice. So I'm going to have x times x gets me x squared minus 7x minus 7x plus 49. Then I'm going to combine like terms on my right side. It gets me negative 14x plus 49. Subtract x and add the 1. I get 0 equals x squared minus 15x plus 50. I'm looking for two numbers that multiply to positive 50 and add to negative 15. That is negative 10, negative 5. Set those equal to 0 using the zero product property. The first one gets me x equals 10. The second one gets me x equals 5. I need to go ahead and check both of these answers. So the first one I'm going to plug in is the 10. So 10 minus 1 gets me 9. 10 minus 7 gets me 3. Square root of 9 is 3. This one works. Then I'm going to do the same thing for the second one. I'll plug in that 5. On the square root side, I get 5 minus 1 is 4. On the other side, I get negative 2. Square root of 4 is positive 2. Does not equal negative 2, so only the 10 works here. On G and H, I have my exponents. I have this written as an exponent, so same thing. I multiply by the I raise it to the reciprocal exponent, so I square both sides. This one is going to get me 2x plus 15 on the left equals x squared. Again, I want to move over all of my terms to the right side. So I'm going to subtract 2x, subtract 15. I get 0 equals x squared minus 2x minus 15. I'm looking for what multiplies to negative 15 and adds to 2x. That is negative 5 and 3. Zero product property to set them equal to 0. I get x equals 5. X equals negative 3. Then I want to check my work. So on the first one I have 2 times, I'm going to plug in 5 first, to the 1/2 power, should equal to 5. So 2 times 5 is going to give me 10. 10 plus 15 is 25. 25 to the 1/2 power is 5. That one works. Then I'm going to plug in my negative 3. Two times negative 3 is negative 6. Negative 6 plus 15 is 9. 9 to the 1/2 power is positive 3, so that does not equal negative 3. So my only answer here is number 5. Part H, I'm going to raise it to the reciprocal exponent, so 3/2. On the left side, that gets me 6x. On the right side, 36 to the 3/2 I can type into my calculator, which gives me 216. I want to go ahead and divide both sides by 6, which gets me 36. I just need to go ahead and check my answer. So I want to type that in. I'm just going to type it straight in like I see it. So I have 6 parentheses 36, close my parentheses to the 2/3 power, and it gives me 36. This one works. Okay, number 8 says let the graph of g be a reflection in the y-axis, followed by a translation 7 units to the right of the graph of f of x equals the cube root of x. Reflection in the y-axis means that is going to change the sign on the x. And then 7 units to the right means it's opposite the sign, so -7. I don't think there's one on the test that's a reflection in the y-axis. The ones on the test should be reflection in x. So, number 9 says let the graph of h be a translation 3 units down, followed by a reflection in the x-axis of the graph. F of x equals 2 the 4th root of x minus 6. So I'm doing 2 things here. First thing I'm going to do is I'm going to go down 3. So I want to subtract 3. And then my second step is the reflection in the x-axis. That is changing the sign on everything. So I'm going to distribute that negative in. That's going to give me negative 2, 4th root of x minus 6, and then plus that 3 at the end. My next problem says, in a tsunami, the wave speeds in meters per second can be modeled by S of D equals the square root of 9.8 D, where D is the depth in meters of the water. Estimate the depth of the water when the wave speed is 200 meters per second. So this is going to be my S of D. So I want to plug that in. I'm going to have 200 equals the square root of 9.8 D. So the first thing I want to do here is get rid of my square root, because that square root is going over both things. So I'm going to square both sides. That gives me 40,000 equals 9.8D. And I just want to isolate my variable. I'm going to divide both sides by 9.8. So 40,000 divided by 9.8 gets me... How much did it want me to round? It doesn't say. I'm going to round to 81.63. On the test, it should tell you where to round to. And this was feet, or meters. And the next one wants me to find the functions. It wants me to multiply the functions together and divide the functions and then evaluate for the given value of x. So first thing I'm going to do is I want to find f times g of x. This means multiply the two functions. So I have 3x cubed times the cube root of x squared. So I can rewrite this as 3x cubed times x to the 2/3. Because these two x's are multiplied by each other, I can add them together. So that gets me 3 plus 2/3 is 11/3. So that is f times g of x. Oops, what am I writing? Okay, then I'm going to plug in my -8, so f times g of -8 means I plug in -8 into that equation I just found. So 3 times the -8 to the 11/3 power gives me -6,144. Then I want to divide the two functions, so I have f divided by g of x. I have 3x cubed divided by the cube root of x squared, which I can rewrite as 3x cubed divided by x to the 2/3. This one I want to subtract my exponents, so 3 minus 2/3 gets me 7/3 from my exponent. So my function here is 3x to the 7/3. Then I just want to plug in the -8. So I'm going to type that into my calculator, which gets me -384. Same thing for number 12. I want to multiply my two functions. So I'm going to have 3x squared times 5x to the 1/4. 3 times 5 gets me 15. 2 added to 1/4 gets me 9/4. So my function is 15x x to the 9/4. I'm going to plug in 16. So 15 times 16 to the 9/4 is, that's right in the light, 7,680. Then I want to do the division one. So I have 3x squared divided by 5x to the 1/4. The 3 and the 5 I can't simplify anymore, so they stay where they are. Subtracting my exponents gets me 7/4. So my function is 3x to the 7/4 divided by 5. And then I'm going to plug in my 16. So 3 times 16 to the 7/4, and then this whole thing should be divided by 5. Gets me 76.8. Next one wants me to find my inverse function. So I start off by replacing my f of x with y. Then I want to switch my x and y, so I have x equals -3y plus 4. I want to solve for y, so I subtract 4 on both sides. I have x minus 4 equals -3y. I want to isolate my variable, so I divide both sides by -3. I'll have y equals x minus 4 over 3. I don't have to simplify that any further. On b, same thing, y equals -9x squared. Switch my x and y, so I have x equals -9y squared. I want to start off by dividing both sides by -9. So then I have x over -9 equals y squared. Then I want to square root both sides. Because it says x is less than or equal to -0, this one is going to be the negative version of the square root. Oops, I want to change this to my inverse notation too. I forgot to do that on the last one. So instead of y, that one should be f to the inverse power. Same idea on c, so I have y equals x minus 1 cubed. Switch my x and y. First thing I want to do here is take my cube root. So I have the cube root of x equals y minus 1. Then I want to add 1 to both sides. I have the cube root of x plus 1 equals y. So my inverse notation equals the cube root of x plus 1. Oops. This next one gives me two functions, and it wants me to find the following. The first one is my inverse function. So I'm going to start off by writing the function with a y. Then I want to switch my x and y. I want to get rid of the 4 on the bottom of the fraction. So I get 4x equals y to the 4th plus 5. Subtract 5 on both sides. 4x minus 5 equals y to the 4th. I want to get rid of my exponent, so I want to take the 4th root. So my answer is going to be y equals the 4th root 4x minus 5. I want to give back my notation. This one was m. So my m inverse. B is the inverse of k, so I have y equals the 4th root of x minus 3. Switch my x and y. First thing I need to undo here is my 4th root, so I'm going to raise both sides to the 4th power. I have x to the 4th equals y minus 3. Add 3 to both sides. X to the 4th plus 3 equals y. Then put it back into notation. So k inverse equals x to the 4th plus 3. On C, I'm doing function composition, so I'm plugging the k function in for the x value on my n function. So I have k of x. So I have the 4th root of x minus 3, and that's going to be raised to the 4th power, plus 5 over 4. So then I want to simplify. Anything that's the 4th root to the 4th power cancels out, so that's just x minus 3 plus 5 over 4. So simplifying, that gives me 2 on the top, 4 on the bottom. So I'm just going to rewrite this. I have m of k of x equals x plus 2 over 4. It's okay to leave it like that because I can't simplify any further. D is plugging in 19. So because I know that one, I'm going to plug in 19 for my x. So 19 plus 2 is 21 over 4. I'm going to leave it like that because otherwise it gives me a decimal. Next one wants me to find the domain of m. So this one is going to be all real numbers, so negative infinity to infinity, or the phrase all real numbers. This is because I can plug in anything for my x. On E, this one has the radical, so I want to take that and set it greater than or equal to 0. Then I add 3 to both sides. X is greater than or equal to 3.